Hey everyone, the Mafia 306 here with lesson 2.1 in the Let's Learn Calculus series. And it's kind of late and I'm kind of tired, so this is probably going to be a pretty quick video. This video is on limits, informally calculating limits. Calculus is all about limits, so this is a good place to start. And if you haven't watched the first video in the series, I highly suggest that you go back and watch it, otherwise you might be a little bit lost as to what's going on here. So, in calculus, we have the following definition. We can write that the limit of f of x as x approaches a is equal to L. And we can write that if we can make the values of f of x as close to L as we like by taking x sufficiently close to a on either side of a, but not necessarily at a itself. So basically what that means is, if we want to find the limit at x equals 1, for example, like in this following problem, then we just take different values of x as it gets closer and closer to 1. So for example, we want to know what the limit of x minus 1 over x squared minus 1 is as x approaches 1. So we start off by saying, okay, let x equal 0.5. So then f of x is 0.6667. Then we let it equal 0.9, and we get f of x equals 0.526316. We go to 0.999, we get 0.500250. And at 0.9999, we get 0.500025. So, as you can see, the values of f of x are getting closer and closer to 0.5 as x gets closer and closer to 1. So, we can write that the limit as x approaches 1 from the left, since all of these values of x are less than 1, is equal to 0.5. Now, similarly, we can do the same thing for values greater than 1. So, for example, at x equals 1.5, f of x equals 0.4. And at 1.1, x equals 0.476. And at x equals 1.001, we have that x equals 0.49975. So, again, as x gets closer and closer to 1 from the right, then f of x gets closer and closer to 0.5. So here we write that the limit as x approaches 1 from the right, and we denote that by adding a little plus sign here next to the 1, is equal to 0.5. Now, that's our right-sided limit. And if you saw earlier, we had the left-sided limit as x approached 1 from the left when we took x equals 0.5 and 0.9 and 0.99 was also equal to 0.5. So since the left-sided limit equals the right-sided limit, then we can say that the limit as x approaches 1 is equal to 0.5. And now notice that we can say that even though the function itself is not defined at x equals 1. It doesn't matter what it is at x equals 1. Whether it's 2, 5, 10, or infinity, or it's undefined, or whatever. It doesn't matter. The only thing that matters is what happens to the values of f of x as x approaches 1. So, not too difficult there. Now, as you know, the function doesn't have to be exactly defined at the point. But if it is, such as x squared, let's say the limit of x squared as x approaches 0. We want to know what the limit of x squared is as x approaches 0. Since x is a polynomial, x cubed, x squared, x to the 4th, x to the 5th minus 3x squared, anything like that, all we have to do is just plug in the value of the limit and we'll get the limit. So limit of x squared, we can just plug in 0 here, so we get that it's equal to 0 because x squared is equal to 0. So that's a little shortcut that you can use if you ever get into that situation. Now, the problem is sometimes we don't know just how close to a we have to take the value of x in order to be sure that we've arrived at the limit. So let me just give an example of that really quickly. If I can find one in here. And it's going to be back this way. Okay. We're going to let f of x equal x cubed plus cosine 5x over 10,000. F of x equals x cubed plus cosine 5x over 10,000. And we want to investigate the limit of f of x as x approaches 0. We want to find the limit of f of x as x approaches 0. So here's our table, x and f of x. Okay. I'm just going to write down some of these values here, and I'll discuss them in just a second. Right. So at 1, f of x is equal to just over 1. At x equals 0.5, f of x is 0.12492, and so on down to x equals 0.01, and we get 0.00101. So here we can say that it appears as though the limit as x approaches 0 of f of x equals 0. And that's what it looks like is happening. It looks like the values of f of x here are going to 0. However, this time our guess is wrong. And if we look at even smaller values of x, we'll see why. And let me write those down really quickly. So, as you can see, with smaller values of x, we are actually approaching the value 0.0001. We're actually approaching this value as x goes to 0, and this is actually the limit at the point x equals 0. So that's one of the pitfalls in guessing the values of limits, because that's basically what we're doing right now. We haven't actually formally or precisely defined a limit. We'll do that here in the next couple of videos. But for now, the way to calculate limits is to just plug in different values of x as it gets closer and closer to this value that you're wanting to find, and find out what happens to the values of the function as you get closer and closer to that point. So that's that. Do we have time for this? Yeah, we've got time for this. Go ahead and knock this out. I'm going to erase my board. Right. Now, let's look at the limit of the natural log of x as x approaches 0 from the right. Right. Limit of the natural log of x as x approaches 0 from the right. Obviously, the natural log of x is not defined for negative values of x. I'll go on ahead and draw the graph for you. Here's our graph. So we're expecting that the values of the natural log of x as x gets closer and closer to 0 are just going to become more and more negative. And so we can see that that is precisely what happens. I don't have actual values for this, but what we wind up having is that this limit is equal to negative infinity, because the values just get smaller and smaller and smaller and smaller. You know, they get more and more negative here as x gets closer and closer to 0. So here we say that the line x equals 0 is a vertical asymptote of our graph. And we know it's a vertical asymptote because the limit as x approaches the value 0 from the right equals negative infinity. So what we can say, we have a new definition now for vertical asymptote. Let me write that down really quickly. Right, so we say that a line x equals a is a vertical asymptote to the graph of f of x if we have one of these four possibilities. We can have the limit as x approaches a from the right equals infinity. We can have the limit as x approaches a from the left equals infinity. We can have the limit as x approaches a from the right is negative infinity. Or we can have that the limit as x approaches a from the left is negative infinity. And that's what we've got here. The limit as here a equals 0. So we've got the limit as x approaches 0 from the right equals negative infinity. So thus the line x equals 0 is a vertical asymptote to the graph of the natural log of x. So I know it's a lot of information. It's very quickly explained. If anybody has any questions about this, feel free to shoot me a comment in the video. But yeah, that gives you a basic idea on how to calculate the limit of just about anything, really. I mean, this method, the pitfalls are that, this method is just a way to guess the value of the limit. You're not actually finding the limit, where you can prove and say, yes, this is the limit. But it will allow you to guess what the values of the limit are. Next video, we'll go over some limit laws that can be used to more quickly calculate limits rather than having to plug in all these values and see what's happening. And after that, we'll go to the formal definition of a limit, and then we'll talk about continuity of functions and limits at 0 and limits at infinity. So thanks for watching. If you have any questions, feel free to leave me a comment, and I hope you all stick around for the next video.